Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Welcome to mathematics class. I am Miss Siberu Favor, and today the topic before us is logarithm. We're looking at logarithm. Now, what is logarithm? Logarithm simply means power. The power of a number is logarithm. That's just the whole thing. Logarithm means power. So it can also be called an exponential. It is logarithm. So here, when we have a logarithm of number x to base b, is the power to which b must be raised to produce the given number x. Now we'll get to understand it better when we proceed. Now the logarithm of x to the base b is written this way: log x base b. The subscript here is the base. Now this is the log, so log x base b simply means how many times we multiply b to obtain x. So that's why we said logarithm simply means power. Now, you know, if this is, we say the logarithm of x to the base b is equal to y. So if I have log x to base b and I say it is equal to y, I am simply saying b should be raised y times to give x. b must be raised y times to give x. Now, just as we have in this example, log 8 base 2 is equal to 3. Log 8 base 2 is equal to 3. Now this means 2 must be raised to a power of 3 to obtain 8. That is what logarithm is all about. That is the power to which 2 must be raised to give 8. Now we will because we say to multiply 2 3 times 2, that is when we have 2 times 2 times 2, we'll have 8. That is the logarithm of 8 to base 2 is 3. That means 2 must be raised to a power of 3. 2 must be raised 3 times to obtain 8. Now also we have log 25 to base 5 equals to 2. Log 25 to base 5 equals 2. That means the numbers of times 5 should be raised. The power to which 5 should be raised to obtain 25 is 2. So 5 raised to the power of 2 will give 25. So we'll say the log of 25 to a base of 5 is 2. Now, what is the log of 10? Log of 1000 to a base 10. Log of 1000 to a base 10. That is simply asking how many times do you think 10 can be raised to give 1000? How many times can you raise? Well, what power? Yes, that is the word. What power can you raise 10 to give a result of 1000? And here 10 will be raised to a power of 3 to give 1000, because when you have 10 times 10 times 10, it will give 1000. So the numbers of time, that number of time you have to raise 10 so as to obtain 1000 is the logarithm of 1000 to base 10. Okay? So the base of logarithm can be any positive number. Yes, please, the base of a logarithm must be a positive number. And when the base of a logarithm is equal to 10, such logarithm is called common logarithm. It is possible to have numbers just like we had log of 8 to base 2 to be equal to 3. Now, you know, in that case, the base is not 10. But when we have a logarithm to a base of 10, it is called common logarithm. Now, there is binary logarithm where you have the base to be equal to 2. And here in this class, we are going to be looking at the common logarithm. We are going to be looking at the common logarithm. And when you also have a logarithm that the base is equal to an exponential function, it is called the natural logarithm. For this class, that is not our focus. We are looking at the common logarithm. Now, before we proceed, we will look at the laws of logarithm. The laws of logarithm. Now, the first law we have there, we have the product law. The product law, and this will be referring us to our laws of indices because it is almost the same application. So we have product law. It says that log a to m times n will equals log m to base a plus log n to base a. Now in this case, this is multiplication in here, but because they have the same base, they will be added. You know, in the laws of indices, when you have numbers of the same base multiplying themselves, you simply add the powers. So that is what we are doing here. Remember, I said logarithm means power. So if I find the logarithm of m to base a and the logarithm of n to base a, I will be adding them to obtain my solution. So example, we have log of 4 times 8 to base 2. The log of 4 times 8 to base 2. Now, if I find the log of 4 to base 2, I am going to also find the log of 8 to base 2 and then add them together. So here, the log of 4 to base 2 is 2. Now you ask how? Remember we said that this log of 4 to base 2 is asking how many times can 2 be raised to obtain 4? How many times can 2 be raised to obtain 4? And you remember when you have 2 times 2, it will give 4. So 2 will be raised to a log of 2 will be raised 2 times to have 4. So that is the logarithm. That very number to which it is raised, the numbers of times it is raised, is the logarithm. So we have 2. Now, the second part, this is how many times can 2 be raised? What will be the power that 2 will be raised to so as to obtain 8? And 2 will be raised to a power of 3, because when we have 2 times 2 times 2 times 2, we obtain 8. So that is the logarithm. Added together, we will have 2 plus 3 and 5. So that's about the product law. Also, we have the quotient law. The quotient law, which is also the division law. It states that when you have a log of the same base dividing themselves, you simply find the logarithm and subtract. Just as our laws of indices, you subtract that power. So here we have log 27 over 9 to base 3. Log 27 over 9 to base 3. Here they are dividing themselves. But remember, this log here is common to the two of them. So this log 27 to base 3 minus log 9 to base 3. So if you find log 27 to base 3, that means how many times can 3 be raised to obtain 27? How many times can 3 be raised to obtain 27? And 3 will be raised 3 times to obtain 27. Yes, 3 will be raised 3 times to obtain 27. And also for this side, how many times can 3 be raised to obtain 9? 3 will be raised to the power of 2, which is the logarithm, to obtain 9. So 3 minus 2 equals 1. And that is that for that. Just the power to which a number will be raised to obtain a particular number is the base. The power to which a number will be raised to obtain a particular number, that power itself is the logarithm. Okay, now also there is an exponential law where the logarithm will carry a power, where you have log x to the power of k base a. Remember, this is carrying a power. Now, in this case, when you have a question that looks this way, you will solve by opening the brackets by log a, then you have log x to base a. This power will multiply the whole logarithm, so that when you found the log of x to base a, you multiply it by this power it is raised to. We'll have a better understanding when we look at an example. We'll have log 4 raised to the power of 10 to base 2. 4 raised to the power of 10 to base 2. Now, 4 raised to the power of 10 to base 2. This is equal to this 10, which is the power here. The 10 we have here is going to be multiplying the logarithm after it is being found. So that we will first deal with this log 4 to base 2 multiplied by 10. This is how it's going to look. So this 10 is like coming behind this we have here and multiplying. So first we look at what is log 2. Log 4 to base 2. What is log 4 to base 2? How many times can 2 be raised to obtain a 4? So 2 will be raised 2 times to have 4. That is what we have here. Multiplied by this 10, which is initially the power here. Remember, this is applicable to the laws of indices. So 10 times 2 will give an answer of 20. Alright? So, having looked at the laws of indices, it is important as well to note that the logarithm of a number x to a base x is equal to 1. That is when you have a number which is the same as the base, it will give an answer of 1. Look at this, we have log x to base x is equal to 1. Because whatever x is, in this case, when x is raised to the power of 1, it will simply give x itself. So anything raised to the power of 1 is still that thing. Also, we have 2 raised to the power of 2 will give 1. So a log 2 to base 2 is equal to 1, because 2 raised to the power of 1 will give 2. 7 raised to the power of 1 will give 7 as well. And so on. Now, it is also important to note that the logarithm of 1 to any base is equal to 0. The logarithm of 1 to any base is equal to 0. Remember, any number raised to the power of 0 is equal to 1. So, if I am saying log 1 base x is equal to 0, where x can be any number at all. Even if x here is 20, by the time I say log 1 to base 20 is 0, that means 20 raised to the power of 0 will always give 1, irrespective of whatever the number is. Log 1 to base 2 is 0, so that means it is always 1. Log 1 to base 5 equals 0. So that 5 raised to the power of 0 is 1. 50 raised to the power of 0 is 1. 2 raised to the power of 0 will always give 1. Okay? That is where we are stopping for this class. Thanks for watching, and please don't forget to subscribe to our channel.